Hi, my name is Brendan Dewan. I'm in the PHSL 1010 class. It's October 8th, 2022. Here is the sound. And today I'm going to talk about the types of sensory receptors in the peripheral nervous system and then their links to the central nervous system. In this case, I'm going to talk about the five sensory receptors. And I'm going to focus on the nociceptors or the pain receptors that link into the central nervous system and back. So here we go. There are five different types of sensory receptors in the peripheral nervous system. And the peripheral nervous system is basically all the neurons, whether it's a motor neuron or sensory neuron, that send through throughout your body, not including your brain and spinal cord, which is part of the sensory nervous system. But the five different types are thermoreceptors, photoreceptors, chemoreceptors, mechanical receptors, and nociceptors. And each type of receptor responds to a different type of stimuli, and I'll talk about each one in its own slide in the next 5 slides here. The first receptor that we're going to talk about is thermoreceptors. This responds to changes in temperature. As you can see, example, high heat versus low heat. It's stimulated by a change of temperature, varying degrees of heat. It gives the body the ability to detect warm and cold weather in the skin. Works both ways, looking for warmth when cold, or in this case, we have a group of individuals by a fire. They're looking for warmth when they are cold, as I just said. And then when they get too hot or they're too close to the fire, they kind of back up because of the thermoreceptors indicating that it is too hot. And then right there, we just have a little diagram that shows the thermoreceptors in one's skin. Next, we have photoreceptors. These receptors are stimulated by light energy, photons of light. This is kind of how you can see your black and whites, and then also how you can see like beautiful sunsets like shown in that bottom left picture as well. It's located in the retina that convert light into electrical signals, as you can see in the diagram. To the right, you kind of have your cones, your rods. As you can see, your cones are the ones that gives you the lights. Rods are kind of your black and white images. Ganglion cells, bipolar cells, and then your pigment epithelium as well. All right. Then the next slide we have here is your chemoreceptors. They are stimulated by changes in the chemical concentration of substances, and these can include oxygen, pH, and glucose. As you can see in the bottom left-hand corner, we have an individual smelling a lemon, which is kind of activating those chemoreceptors as they smell. And then also, if this individual tastes the lemon, also those receptors will be activated. In this case, the papillae, totally botched that, but that receptor for taste on the tongue, that one would be activated if he was to try the lemon in his hand there. And then on the upper right, we kind of have a diagram of what's going on when chemoreceptors are activated, whether it is through the nose or whether it's through eating something, which allow those receptors on the tongue there to give you the taste. All right. Next we have the metronome receptors. These are stimulated by changes in pressure and movement, respond to pressure, touch, vibration, like I said. This is like touch sounds. As you can see in the diagram, it kind of goes through the diverse class of sensory endings there. And then also in the right image, you can kind of see people shaking hands. That kind of pressure and touch activates those mechanical receptors as well. All right, and then this is the most important receptor. This is the nociceptor. This one has specialized nerve receptors. It indicates pain. It's stimulated by tissue damage. It is the most important receptor as it helps protect us from our outside environment and honestly ourselves too. So like nociceptors can be present in the pictures I have there, as in like a nail going through skin, and then we'll describe how in the next slide kind of how these nociceptors go into the central nervous system and back through the motor neurons down to the leg and all that stuff too. But this one is the most important as it helps, like I said, protect us, and pain is a signal of distress. And these nociceptors are the ones that indicate pain here. But these can be present in like a nail, or maybe in like burning of a hand when you touch a hot pan, because that can activate your thermoreceptors and your nociceptors as well. So some of these can work with each other too. All right, then kind of what we're getting towards is tracing a pain signal using nociceptors to the central nervous system. A lot of these receptors can be traced in the same manner throughout the central nervous system. But you first start with a stimulus that activates your nociceptors as they trigger action potentials to make them aware as they go from no discomfort to much discomfort. Pain sensing neurons produce TRP channels. The TRP channels sit in the cell membrane, each able to respond to a different stimuli. Once these nociceptors are kind of activated, and that stimulus activates them actually, sensory neurons then travel to the central nervous system, and in this case, your spinal cord first. This will lead to the reaction to kind of lift your foot or shake your foot as motor neurons are sent back down the foot. So as you can see in that top left image, you kind of have someone stepping on a tack or nail or anything like that, and then in the middle it kind of shows you the diagram there. But that stimulus is attacked right there. That will end up activating your nociceptors and then going back into your central nervous system and your spine, and then motor neurons will go back down to kind of, once you step on the attack, to lift your foot up as well. Then the sensory neurons continue to travel to the brain, and that's just as the same moment as the motor neurons are traveling back to your foot to lift your foot first, and then the sensory neurons indicate the pain to the foot area, or the brain indicates the pain, and then calcium ions then flood to the cell through the channel, sending a pain signal to the brain as well. Pain, again, it tells the brain to protect ourselves from outside stimuluses that could hurt us, or internal ones as well. But yeah, this was a presentation to kind of go through each of the 5 sensory receptors in the peripheral nervous system, and then I wanted to link the nociceptors back to the central nervous system, as that is the most important sensory receptor in the peripheral nervous system, but also the other 4 can also link back to the nervous system too in their own ways. Well, I appreciate it. Thank you for watching and listening today. Thanks.